Okay? The product rule for exponents that says that whenever you have a base raised to a power, and then you have that same base raised to a different power, the rule says that we're going to add those exponents. So how many of us remember this very first property here? Okay, yes. So it doesn't matter what the base is. The base can be a number. It can be a variable. So for example, we have here 5 squared times 5 to the 6th power. Now all I want us to, we want to use the product rule to simplify. Now what I don't want you to do is to multiply the bases. That's not what the rule says. The base says to keep the rule says to keep the base the same, your base the same, but add the exponents. And we have here 5 to the 8th power. Okay. Number 2, we have here x to the 5th times x to the 9th. Common base is x, and we're going to add the exponents. 5 plus 9, we have x to the 14th power. Number 3, we have here y times y to the 4th times y cubed. When there's a standalone y and there's no exponent that's shown, it's an understood what? 1. So you're saying y to the 1 plus 4 plus 3, and we have y to the 8th power.
What if the bases aren't the same?
If the bases are not the same, we cannot add the exponents.
So you just leave it at that?
We just leave it as that, yes. Yeah, we will have some where we have x and y and z and all of that. And this is let's do a couple of those, okay? We have here 7y to the 5th times 6y. Now, since we are dealing with factors, meaning we are multiplying, we're going to combine like factors, not terms. Terms are when we are multiplying, or when we're adding. But when you have multiplication, it's factors, meaning we're going to combine our coefficients, 7 and 6, and our y's. So 7 times 6, we have 42. And you're saying y to the 5 plus 1, and that would give us 42, y to the 6th power. Let's do one more. One more with this property here. We have the quantity of negative 3 x squared y to the 7th times 5 x y to the 6th, okay, times the quantity of 5x y to the 6th. Similar to number 4, we're going to combine like factors. Our negative 3 and 5. Our x's, x squared, x. Our y's, y to the 7th, y to the 6th. You're saying negative 15, x to the 2 plus 1, y to the 7 plus 6. And we have our solution of negative 15, x, what? Cubed, y to the 13th. And that is a 13, y to the 13th power. All right. So any questions with the very first property? Okay, now, did we all get this here? No, go ahead. Go ahead. Now, our second property, which is the zero exponent property, it says anytime you have a base raised to a zero power, it is 1. It is 1. Read it one more time. If a is a non-zero real number, then a to the 0 power equals to 1. Okay, here's example 2. We have here 8 to the 0 power, which is what? 1, yes. Number 2, we have the not quantity, but we have the opposite of 8 to the 0 power. So my question to you is this one: what is being raised to the 0 power? The negative, the 8, or both? The 8. Just the 8. Because if I want, I'm going to make this number 3. If I, wait 1 second. If I place the negative, parentheses around the negative and the 8 raised to the 0 power, that whole quantity is being raised to the 0 power, so it is 1. So for number 2, what is being raised to the 0 power is just the 8 only. So yes, it will be negative 1. So you're saying negative times 8 to the 0. Negative times 1 will give us negative 1.
2 is negative 1.
Huh?
For 2 is negative 1.
For 2 is negative 1. That's just like, let me think, if I gave you negative x. Think about it. What is the coefficient of that? Not just 1, but negative 1. If I gave you negative x, what would be the coefficient? It would be negative 1. So in turn, you're saying negative 1 times x. So this is what we're saying here. Negative times this 8 to the 0 power. Let's see. I want to at least finish this page here because I want to go to Math Excel. The quantity of y minus 3 all raised to the 0 power. Let me say this. When you have parentheses around, and then it's raised to the 0 power, it doesn't matter what's inside the parentheses. It's going to all be 1. Because at the end of the day, you're saying y minus 3 all over y minus 3. You're dividing that into itself, so it's going to give you 1.
If there was no parentheses there, then it would just be for the negative 3, or just for the 3.
It would just be to the 3, then it would be y minus 1. If you're saying 3 to the 0 power, we would do 3 to the 0 power, and it's just y minus 1, and there's nothing that you can do about the rest of it. That's the answer. Okay? Yes, it is. Question?
You said it would be y minus 1?
It would be y minus 1. The question was if there was not a parenthesis there around the y and the 3, but the 0 would be next to the 3. So here, we'll make it into a question. Y minus 3 to the 0 power. What is raised to the 0 power is just the 3, not the y. So all you can do with the y is just bring it down. We know 3 to the 0 power is 1. And we can't subtract y and 1. They're not like terms. So it stays as this, as a binomial. Last one.
So it's y minus 1?
It's just y minus 1, yes. 5x to the 0 power. You're saying 5 times x to the 0 power. X to the 0 power is 1, and multiply 1 to the 5, and we have 5. Okay, last set of examples. Okay? And then we'll finish out the rest of the rules on next week. Quotient rule for exponents. The opposite of the product rule. Quotient means we're dividing. Okay? If A is a non-zero real number and M and N are integers, then A to the M over A to the N is equal to A to the M minus N. Basically what this is saying. You have a quotient, you have expressions raised to a power, and that base, they're the same, you're going to subtract. Okay? That's what the rule says. So, make this example 3. Number 1, we have here y to the 6th over y squared. See, before, especially in prep, the first prep or first developmental class, I will have the students write out how many y's do they see. This is what we did before. Okay, we had 6 y's over 2 y's. Then we would simplify. We can divide out 2 sets of y's. And then we're left with y to the 4th power. But the reason why we have this shortcut rule, because what if this exponent, instead of 6, it was 60? And this 2 was 20. You don't want to have to write out y 60 times and then y 20 times. That's not what we want to do. It says here, you have a base raised to a power, and you're dividing, you have the same base raised to a power, subtract. Keep the base the same, and whatever number that is that's in the denominator, you're going to bring it up and subtract it to the number, to that exponent in the numerator. So you have 6 minus 2, we have y to the 4th power.
So when it comes to division,
You're going to subtract, yes. Number 2, we have here 36 x to the 5th all over 9x. So just like with the product one where we had to combine like factors, well, we're doing the same thing here, but we're dividing. 36 divided by 9. Okay. So yeah, 9 divides into 36 4 times. And then this is how you would show the work, and I'll show you the shortcut come Monday, okay? You're saying 4x to the 5 minus 1, because we all understand that this is an exponent of 1. And then we have here what Desi said, 4x to the 4th power.
What if that was like 38 over 9?
Then we would say 38x to the 4th all over 9.
Okay.
That's what we would do. Because if it can't be reduced as part of the question, it has to be part of the solution. Mm-hmm. So, last one, we have here 10, a to the 7th, b to the 9th, all over 15, a to the 5th, b to the 9th. Now, 15 can't divide into 10, but we can reduce 10 over 15. 2/3, yes. Look at your b to the 9. You can cancel those out. You can say b to the 9 minus 9, which is b to the 0 power. In turn, that would give you, okay, you can divide that out. So this is, if you want to see the work to this, you're saying 2, a to the 7 minus 5 all over 3, and then we have 2 a squared all over 3, or we can say 2/3 with the a squared kind of halfway between the fraction.
You have negative exponents too?
We would be talking about negative exponents. Now, with negative exponents, we're going to have to, the rule says take the reciprocal. Because in order for our exponents to be in simplest form, the exponents have to be positive. So we're going to have to do some reciprocating. Okay?